Animal restoration projects are an important part of ecological restoration. Ecological restoration, for the most part, focuses on restoring the plants and the soil and the topography and the hydrology. But as you know, the plant systems in an ecosystem are what support the animals. And so sometimes, well, you have to do the plants first, but animals are also restored to ecosystems sometimes. The animal restoration projects are perhaps the better known aspect of restoration, or they're more newsworthy. For example, the gray wolf restoration into the United States. There's a lot of text here, and let me try to summarize it for you. In general, gray wolves were predators. They sometimes attacked livestock on ranches, and so they were shot and killed, and we tried to control them. And basically, they all of the gray wolves were killed in the United States by around the early 60s. So they were all gone except for in Alaska and maybe in the very northern Minnesota. And the Endangered Species Act was passed a few years after that. And by 1974, the gray wolf was one of the first species to be listed as federally endangered according to the Endangered Species Act. And a recovery plan, it took about 20 more years for the biologists and et cetera to create a recovery plan. And in 1995, gray wolves were reintroduced to Yellowstone National Park in Idaho. Wild wolves from Canada, where the wolf populations were and still are very strong. Some of the wolves were taken from Canada in the wild, tranquilized, and brought down to the United States and released. And actually, these did really well. These often wild animals that are relocated into a new place as far as are involved in a restoration, they tend to be fairly successful as opposed to captive bred wild animals. So if you took wolves like this and then kept them in a kennel and bred them to have more wolves, and then took those wolves that were raised in the kennel and put them back out into Yellowstone, they would not likely chances they would not do well on their own. And it kind of makes sense they're not adapted to the wild. But these did pretty well. I used to work for the Forest Service, as I think I've mentioned, and worked with a lot of Fish and Wildlife Service people. And this is a picture of a Fish and Wildlife Service person releasing one of those tranquilized wolves from Canada into Yellowstone. And let me tell you, she's not the typical Fish and Wildlife Service looking person. Most of those people were pretty rough looking. So I think this was a model just for this photo shoot. Of course, there were protests, a lot of ranchers in the Yellowstone area, and they were very concerned that this animal, which had now been considered an enemy and bad, was being brought back. I mean, just imagine it, like you've got from the, you know, mid 1800s, 1850 to 1950, almost 100 years of, and 5 generations of humans, people growing up saying when they heard, I can imagine some of these people, they're putting their kids to bed and they heard a wolf, they would be, those people would be concerned and they'd be telling their kids like, oh, that's the wolf, you always be careful of the wolf, he's dangerous, he's bad, he eats our livestock. So this is 100 years of that kind of lore or talk about the wolf being bad. And so for the government to now impose this recovery plan where they're going to bring them back seemed completely ridiculous to these ranchers. When a animal or a plant is going to be try to be restored in an area or enhanced, meaning they're on the endangered species list, so there's not very many of that plant or animal or organism left. So the U.S. Fish and Wildlife Service is charged to write a recovery plan, which outlines how they are going to get that organism off the endangered species list, gets the numbers of those organisms back up to a level where they're not endangered anymore. That's what this is an example of a recovery plan that they wrote for the wolf. How are they going to get the numbers back up so it's no longer endangered? Of course, the people did not like I said, the ranchers didn't like it. But when you look at the data, cattle, livestock are a small portion of their diet. Mostly wolves eat elk, and then they eat some other species, and even a smaller portion, less than 1%, is actually livestock. So from the wolf's perspective, their habitat has suddenly been taken away. We've put ranches all over their habitat, and we're forcing them to eat or try to eat something that they would never normally eat, but they're so hungry because their habitat has been changed over to ranch land that they are pushed to eat these marginal food sources, which are livestock. So it's kind of like sharks. You know, sharks do not want to eat humans. They want to eat seals, but they still don't. They don't. Rarely do they actually eat a human. They usually bite them and then they spit them out because they don't like them. So same thing with the wolf eating livestock. It's really not their top food choice, but the wolves are, often portrayed as evil and awful and bad. So check this video out here. I do want you to look through it. There's some really good information, and it's beautifully done too. But it's really important to think about how valuable and critical a predator is in an ecosystem. So let's think about the wolves and the elk in the Yellowstone National Park ecosystem. Um, you you can imagine bringing the wolf back. Now all those elk which have not had a predator suddenly have a predator, so elk numbers will go down. But this video illustrates the cascading ecological effect that a predator has. Um, once you bring this is what happened once the wolf was reintroduced and the population started to expand because the wolves were doing well. The elk population went down. What do elks do? Elks are herbivores. They eat plants. Well, a lot of the plants that had been eaten down to the ground because there were so many elk and no wolves for a long time in that Yellowstone area, the plants had overgrown. Excuse me, the opposite. They had been eaten down to the ground, almost nothing. So what you saw was a lot of erosion that happened in the rivers. The river banks were becoming destabilized because all the vegetation was um, eaten by the overabundance of elk, and that caused problems with the rivers. And when you get all of the riparian, those are plants that live around a river or creek, those riparian plants, once they're eliminated because of the overabundance of elk, then you also have all those riparian species like birds and other things that usually go to those creeks. They have to leave. So the lack of wolves really was a problem, and the reintroduction caused some big positive ecological benefits. As I said before, a small portion of reintroductions of captive bred animal individuals are successful, but the majority, 86% of reintroductions of native wild game animals or native wild animals like the wolves are successful. About half of the reintroductions of native, threatened, endangered, or sensitive animals have been successful. So that would be more the category of the wolf, would be that second one, because these are wild animals and they're not game animals. Santa Cruz Island restoration is probably the best example around here of a reintroduction of a wild species that had gone extinct. The island fox is native to 6 of the 8 Channel Islands, and actually on each island there's a different distinct subspecies of the fox because the islands have been isolated from each other for so long. The genetics become unique amongst certain plants and animals, and the fox is one of them. In the 1990s, a decline in island fox population was identified. There's kind of a chain of events that led to the island fox decline. Golden eagle predation. Um, the golden eagle started to move in to the area once the bald eagle started to have problems because of the too much DDT in the ocean system that came from our agriculture. The high levels of DDT, it's a pesticide that's now outlawed. high levels of that DDT, which concentrated in fish, would be eaten by the bald eagles, which are native to the islands, the Channel Islands. And then the bald eagles, when they laid their eggs were the shell was so thin that when the female bald eagle sat on them, they would crack, so they could not raise young because the DDT made the eggshells so thin. So the bald eagles started to decline for that reason. The golden eagles, which is an omnivore, so a side note that the bald eagles only eat fish, so they are fish hunting birds. So that's all they ate. But the golden eagle is a little bit bigger. It's all brown. It can eat anything. It can eat stuff on land animals, and fish. So it started moving in when the bald eagles declined, and it also would eat the baby foxes too. So there was one problem there. Um, Actually, this one of my boss's husband. I worked for this woman with the Forest Service. Her husband worked for the Fish and the Wildlife Service. He was a contractor, and he would go out and take the eggs out of the bald eagle nests right when they were laid. They had ways they'd check the nests often, and as soon as they were laid, they'd take them out and they'd take them to a lab where they'd incubate them until they hatched and put the hatchling back to get around that weak eggshell problem. Um, so the golden eagle replaced the bald eagle and began to feed on the foxes, but feral pigs were also brought into the islands, or to Santa Cruz Island for hunting, but they went wild and they were all over the place, so that the golden eagle population loved that, but also would eat the foxes. And then the feral pigs caused all kinds of damage to the vegetation because there were so many of them. So what they finally did, and this wasn't that long ago, it was about 19, excuse me, in the early 2000s is when they decided these island foxes were put on the endangered species list, and they spent millions and millions of dollars to eradicate all the feral pigs, which took a couple of years, and to also breed the Channel Island foxes in captivity and then reintroduce them to the islands. They did to Santa Cruz Island after all the pigs were gone and the golden eagles had left. So they brought them back, and it's been successful. If you've gone to the Channel Islands or Santa Cruz Island anytime in the last 10 years, there's plenty of island foxes out there now. So it was a successful reintroduction. Sometimes restoring a site might just be the increasing the volume of water, the flow of water, like in this restoration of a creek, a riparian area in Washington. You see the picture of the beforehand, the water level was too low because of damming and channelizing and water that was taken out of this creek, and they allowed the natural level of water to come back, and it filled it up more, and that allowed the vegetation to restore as well. There were some plantings done in this one as well, but sometimes the perturbation is just water flow. That's true of the airport and the lagoons around UCSB. Is A lot of those lagoons used to have tidal flow come in and out. The tides would push water into the fresh water and caused brackish water in those wetlands, and then it would empty itself back out in a low tide. But dikes were built, little berms were built to keep the tidal flow out, and that caused ecosystem collapse. And so just reintroducing the tidal flow will help those systems recover. Restoration of garbage dump. This is one of the largest and earliest garbage dumps in the United States. It takes garbage from New York City. It's in Staten Island, New York. It's called Fresh Kills. This is just a picture of it now. You can see that it's an ecosystem for garbage and seagulls. But that has been successfully restored. Restoration might be a big word for really what was done. It was the garbage was deemed full, the dump was deemed full, and they put soil on top of the dump and then planted different grasses and shrubs and some trees on top of it, and it looks like this now. Coal mining, when we do get coal for burning for fuel and electricity, it's an ore that's down below the topsoil and the subsoil. So we've got to strip mine, take off all the vegetation and the plants and the animals and the topsoil and the subsoil, and dig down to get it. And it often leaves coal mines just big open pits. But now it's still a big problem. But one thing they've developed as far as restoration goes, again, this would probably be called mine reclamation, not really restoration, because we're not really in these situations, they're not really restoring the ecosystem. They're just trying to get a little bit of soil and vegetation back. You can see in the picture on the left, it's a sequence there, like the very top right side of that mountain, you can see a forest. And that was probably mined 25, 30 years ago. And then it was covered with soil, planted, and it's the most mature, the oldest part of this mine reclamation. Just to the left on top of that hill is just a little bit younger site, not yet forest. And then you work your way down. You can see the more recently mined areas where they've covered it with some topsoil, and then some has been seeded with some type of quick growing vegetation. When I worked for the Forest Service, I worked in the Big Bear area, and this is just a picture of one plant that was federally listed on the endangered species list. And this plant was endemic. It only grew on limestone outcrops in the Big Bear area in the San Bernardino National Forest. Unfortunately, those limestone um, minerals were also wanted by mining companies. They were under mining claim. So the mining law, which was enacted in 1872, allowed anyone to come out, well, mostly the Western United States, and stake a claim and say, I've found a mineral here that I want to mine. I'm going to stake a claim. Now I can mine this, and I have the right to mine it once they've gotten that claim. So unfortunately, all of this little milk vetch plant that's growing on the limestone is also under claim by mining companies. So there was a big rub there between the Endangered Species Act, which is saying we need to protect this species, and the mining law, which says miners have the right to mine that limestone. So it's very interesting and as controversial in my mind as like the gray wolf reintroduction. My boss, who helped write the plan to save and protect these milk vetch plants, I mean, she had a death threat voicemail left for her once because these miners were so angry about having some of their minerals and mining rights taken away. There's restoration done in the desert too. This is the Mojave Desert. I worked in the Joshua Tree National Park to do some restoration of desert plants along the roadsides. Mitigation, let me just talk about mitigation for a minute. Mitigation technically is the alleviation of some process. So it could be anything. But when we're talking about restoration, mitigation is often what is required when some group wants to develop a wild area, such as a wetland, and destroy the wetland. So, for example, let's say Target, we don't have Target in Santa Barbara. Let's say Target wanted to put in a new store somewhere, around here in Goleta. And so they were going to damage, like basically bulldoze off of the native plants and put Target there. Well, these days, if that area is natural, um, some kind of plan would have to be created that says, okay, if you're going to destroy the wetland or natural coastal sage scrub around here, um, we have to write a plan so it doesn't destroy too much of it, and you have to mitigate, meaning you have to try to lessen the effects that your target is going to have on the environment. So that would be one way that mitigation is involved and used as a way to protect environments, to keep them from getting damaged as much as they possibly could if there were no regulations. When I was in Oklahoma once, I was looking for a certain type of aquatic plant to use in some crafts we were doing with the Miami Indians. And I couldn't find any of that plant. It grows in wetlands. It's called a bulrush, and I went to Walmart to do some shopping because that's one of the very few places you can shop in the area of Oklahoma I was. And then I drove around the back just because I saw something interesting in the back. It looked kind of like a little, I don't know, some cattails and a little wetland. I drove back in there and I saw like maybe it was a 1 acre little wetland, and it was a restored wetland. So that wetland behind Walmart was created, and this is an example of mitigation. So I'm sure when Walmart wanted to put their new building there, um, there was some biological review that said this where Walmart wants to build will actually destroy some wetlands. So as a mitigation, the Walmart company and the contractors that were helping them with this created this plan saying, well, we will mitigate the damage of the wetland by our new Walmart by building another, restoring or recreating a wetland behind our building. So that would be considered a mitigation. So another way to say this, or bigger picture, is when someone like a business owner um, wants to develop a site that's natural, they apply to the county usually for a permit for building. And the county will have biological reviews done, amongst other things. And if the biological review by the county says, no, you know what, you're going to damage a natural area or hurt an endangered species habitat, they will say no on the permit. And then that entity like Walmart might say, well, we're going to mitigate the damage to that organism or that natural area by creating a wetland or building habitat for that endangered species somewhere else. That's a mitigation. And then often the county will say, okay, now you can have your permit. So mitigation is often used as a way to less alleviate the damage of some kind of new development, but it also sometimes can be used as a kind of a political bargaining tool to make sure that development still can happen and isn't stopped by endangered species or things like that. And that's kind of what this slide says. But the big problem is that mitigation projects, their success, like that wetland behind Walmart, it was just this little dumpy little wetland. It had about 6 different types of plants, and it was in like the storm drain right behind Walmart. It was not a real um, ecological wetland system. It was a poor example. It was not very diverse, and it was not making up for the damage to the natural pristine ecosystem. So these mitigation projects sound good, like, oh, we're going to ruin a wetland. We can just build a new one over here. Sounds good, but we don't really know how to make wetlands that well. We can kind of do it, but they're usually not nearly as successful, meaning they don't last very long, they die out, and they don't provide the same functions as a natural system. This graph is just talking about different ways that we can restore sites. So one way would be looking where you see that big circle, the lower left part of the graph, that is a degraded ecosystem. So we can do nothing, that would be the neglect arrow, and the structure, the x-axis, and the function, the y-axis, of that ecosystem will improve. You can see the arrows pointing up to the right. So the structure and function will slowly heal and get better sometimes if we do nothing. Sometimes if we do nothing, the system will go backwards. It'll actually get worse. So we can't always take the hands-off approach like that nature's always going to heal itself if we get out of the way. Sometimes we can rehabilitate sites. So it's not really a restoration. It's just kind of making it a little bit better. That's kind of like the mine reclamation with the coal mining. I mean, a forest, even though it's not very diverse, is better than just a big open coal pit. The big black dot in the upper right, that would be we actually restored all the function and structure to that original system. So it's as strong as original. Sometimes we can make it even a little bit better. But Really, if you talk to restoration ecologists, it's a very young science. We know very little about it. And so it should be used very, very carefully, not as the solution to all development that we can always fix everything. I like what this restorationist said, Frank Egler. He says, ecosystems are not only more complex than we think, ecosystems are more complex than we can think. So that's something that can really keep us humble and remind us that an intact, pristine ecosystem that hasn't been damaged is is extremely more valuable than a recreated one or restored one. We should be very careful to preserve and conserve intact natural systems because we really don't know that much about it. Here are the 7 basic steps for restoring an ecosystem. 1. Set a goal. 2. Determine a strategy and methods for how you're going to restore that system. 3. Remove the source of degradation. That could be, again, a dam that's keeping water flow from entering. It could be a pollutant in the water or the soil. It could be an actual predator that is non-native, like the golden eagle. Or it could be lots of things. It could be that there are, dirt bikes going through a forest and ripping up the soil. Stop the dirt bikes and then start to restore. So there's a lot of types of perturbations or degradations to remove. Step 4, restore the physical environment. That would be the topography, the lay of the land, the hills, the valleys, etc., which affects the hydrology, the way the water moves on the land. 5, restore the biota, starting usually with the plants. 6, be patient. We got to let the plants grow, take root, the soil recover, etc. And 7, monitoring and maintenance. So that site needs to be monitored for a while until it looks like it's healthy enough and self-sustaining enough to be on its own.